Good afternoon, everyone. My name is Namakula Josephine. I'm going to take you through the exploratory data analysis of the fintech companies. First of all, I'm going to take you through. I'm going to tell you what are fintech companies. Fintech companies, you can call them like financial technology, which is used to describe new technology that seek to improve and automate the delivery and use of financial services. Fintech is utilized to help companies, business owners, and consumers better manage their financial operations, processes, and lives. So fintech companies, you can also say it is the integration of technology into offerings by financial services companies to improve their use and delivery to customers. So you can ask yourself, okay, what are they? So for some fintech companies, they can include robo-advisors, payment apps, peer-to-peer lending apps, investment apps, and crypto apps, among others. So when I go to the next slide, I find the dataset, which is called the data paper dataset. That is the name to the dataset. So when I go to the next slide, I find a correlation matrix. A correlation matrix is a statistical technique used to evaluate the relationship between two variables in a dataset. It shows the strength, it shows how strength and in what direction two or more variables are related. Also helps us to make good decisions about the data. So the we can see here, this data set has more variables which are negatively correlating and few variables which are correlating with each other. When I go to the next slide, I find a bar graph. A bar graph is used when you want to know the distribution of data points or perform a comparison of metrics values across different subgroups of your data. So we can see using the bar graph which groups are highest or most common and how other groups are compared to the others. So, and we can see here these bar graphs, they are the same compared to this one, which is down here. So when I go to the next slide, I find a histogram with a KDE estimate. A KDE estimate is this line, which is running from here up to here. So the KDE line, it can show us some insights into the distribution of the central tendency and spread. So we can see here that this data, like, it is not left skewed, it is not right skewed, it's there. It can also the histogram, the bars represent the frequency of data points within specified ranges. It is also used to visualize the distribution of numeric data, these bar graphs. This line, it's the most, this KDE line is the smooth estimate of the distribution of the data. So the regression line, the KDE line, we can start, it peaked here between 60 and 80 here, and it was down here. So when I move to the next slide, I find the box plot. The box plot is used to show the distribution of numeric data values, especially when you want to compare them between multiple groups. They are built to provide highest level information at a glance, offering general information about a group of data symmetry. The box plot has 4 parts. The first part is from here up to here. The second part is from here up to here. The third part is from here up to here. The fourth part is from here up to here. This is the mean. This is the upper quartile. This is the lower quartile. This is the higher value in the data set, and this is the lowest value in that data set. You can see this data set, these box plots, they do not have outliers, but when we see here, the mean, it is not located in the center. even the mean of this box plot is not located in the center, but this one is located in the center and this one. So when I go to the next slide, I find the 2-bit paper dataset. The 2-bit paper dataset. This is the link to the dataset. So when I move to this slide, I find a bar graph. So we can see that this data is right skewed here, and this graph here, it is more higher than these values here. We can see it is right skewed from these bars. They are equal, but this bars it is right skewed this side. So when I go to the next slide, I find the histogram with the kernel density. This data, the explanatory variable, it is left skewed. So, and this line, it peaked between 0.0 and 0.02 here, and it went down on 1.0. When I go to the next slide, I find box plots, and here we have plotted some outlier here in 2020. I plotted an explanatory variable with different years: 2018, 2019, 2020, 2020, 2021, and we have an outlier here in this data set in this year, and we also have 2 outliers in this year 2021. So we can see that the mean of this data is not at the center. That is not at the center of this in this year. Even this one, even this one, even this one. So when I move to the next slide, I find a correlation matrix. As I said earlier, it is a statistical technique which is used to evaluate the relationship between 2 variables. Again, we can see that most of the variables in this data set were negatively correlating with each other. The only variable which we got like it's somehow strongly correlating with each other, it is 0.48. This variable with this variable here. When I go to the next slide, I find a pair plot. So a pair plot, it is a combination of both bar graph and scatter plots. So it is also known as a scatter matrix of graphs that enables visualizations of the relationship between each pair of a variable in a dataset. Histograms, these ones which are running diagonally, they show the distribution of single variables, and the scatter plots, these ones here and these ones here, we can call them off diagonal plots. They show the relationship between 2 variables, and these can reveal patterns, trends, and correlations between the data in a data set. So when I go to the next slide, I find a box plot of an explanatory variable against count. We can see that this data here, it had no outliers in it. And the mean was located in the center. So when I move to the next slide, I find the pair plot. So I chose some basic variables from the dataset, and I plotted their pair plots here. We can see, as I explained earlier, these ones, they are diagonal, meaning they show the distribution of the same variable. Here I find the scatter plot with the regression line. So the scatter plot with the regression line. So this line, you can also call it the line of best fit. It shows the overall trend of the set of the data in a data set. When I go to the next slide, I find another dataset which is called Fintechs and so on. That is the link to the dataset. Here I find the correlation matrix. So we can see in this data that most of the variables in this data were highly correlating with each other. So we can see that in I can not see clearly the variables, but you can see that this variable here, it is highly correlating with this variable here, these ones which are running diagonal, they are correlating with themselves. So we can see that this variable here, it is negatively correlating with this variable down here, meaning they have no correlation or connection at all. So when I move to the next slide, I find the histograms with the kernel density. This one shows us how school names, the data is. It shows us the central tendency between the data. Because this data is, this one is right skewed, this one's also right skewed, this one's also right skewed, because that most of the data in the data set were right skewed. They were not in the middle, but this one was in the middle, even this one. So when I move to the next slide, I find two box plots, which I plotted country dummy with NGDP. We can see in GDP, it had some outliers. So when I move to the next slide, I find a swarm plot. You can see. So when I move to the next slide, this is a pair plot. I find a box plots again from the same data set. So the next data set is the German fintech companies, the market overview. So this data set comprises of a handheld collected market overview of the fintech market in Germany as December 2021. It includes various verified properties of 978 unique firms, which can be attributed in the financial technology sector and are operating in Germany. So this data set had many features to compare. So it was a good data set compared to the others. So this is the link to the data set. So it had very many features and inputs. So when I plotted a bar graph. I plotted a bar graph which was showing which fintech is active up to until 31st December 2021, and showed that 82.0% of the fintech companies were active and 18.0% were inactive by 31st December 2021. I considered a year. So I move to the next slide. I find the correlation matrix, and we can see here again, most of the variables were correlating with each other, except from liquidation. Those banks which were liquidated with the again a status, those two were negative correlating. They had no correlation at all with the negative 0.62. This one is the same as this one here. So the upper part is the same as the lower part. The upper part from this diagonal line, this part here, it is the same as this part here. So when you read something here, it means you can also read it from this side here. So when I move to the next slide, I plotted the location. I wanted to know where the most of the fintechs were located, since the dataset had very many features to compare. So I saw that most of the fintechs were located in Germany, followed by England, Switzerland, Australia, USA, Netherlands, Luxembourg, Latvia, Sweden, France, and last in Malta. So these ones here, they had very few fintechs. And when I move to the next slide, again, I plotted the frequency of the fintechs by the segment type. So you can see other fintechs were 15.5% technology and IT infrastructure. There were 13.0% insurance, 11.1%, up to crowdfunding, which had 0.1%. So when I move to the next slide, I find liquidated companies by finding years. So I plotted liquidated companies by founding year. So we can see that in 2000, we had very few liquidated companies compared to 2014, where we had very many liquidated companies. 2020, 2005, 2018, they had the same number of liquidated companies in those years, and they increased by 2020, with 2021 being the same. They increased here in 2012, decreased in 2013, increased again in 2014, decreased 2015, 2016, and 2017. So when I move to the next slide, I find fintech companies count by founding year. The other ones were liquidated companies. These are fintech companies count by founding year. We can see 1921, we had very few, they had very few fintech companies compared to 2015, where they had very many fintech companies. So we can see here in 2000, the companies increased in number, and finally they decreased in 2001 and 2002. Again they increased here. They go on increasing up to when they went on decreasing up to 2021. So when I move to the next slide, I find frequency of fintech sub-segments. These ones were companies by founding year, but these were sub-segments. And here there was fintech we had segments, and we also had sub-segments in the data set. And we can see here other fintechs. You can see their statuses. In their statuses, blue ones, they are 0, 1 there. The blue ones, they represent 0, and this color here, the green, they are representing 1. So when I move to the next slide, I find bank cooperation with bank cooperation. We plotted bank cooperation with insolvency and liquidation. This graph here, it is showing insolvency with bank cooperation. This one is liquidation with bank cooperation. So when I move to the next slide, I find a Fin manuscript dataset. So this dataset, it is here we can see that most of the data in the dataset we are correlating with each other. We don't have much of those dataset, those variables which are negative correlating with each other. So we have them here, here, here. This is the same as this one here, here, here. So we can see the correlation. So we monitor the correlation of these variables by using the key here, which is on the right. So when I move to the next slide, I find a scatter plot with a reflection line in it. So I find the histogram with a KDE line in it. We can see again here, it peaked here at 40. Again, it peaked here in between 70 and 80. 70 and 80, and it went down here after 80. So when I move on, I find a pair plot. I plotted a pair plot of a fintech of index and inequality. So we can see here, this is the pair plot. So when I move to the next slide, I find a box plot for this one. It shows the outliers, and the data was not much, like it had so many outliers. The data was left skewed, as we can see. So when I move to the next slide, I find the data set called the Dell LF. So this is the link to the data set. I go to the box plot. It had so many outliers, and the mean was not at the center of the data. When I go to the next slide, I find a bar graph. It is right skewed, it is left skewed. We can see that most of the data is located in this side. So this is the distribution of respondent ID. Yeah. So when I move to the next slide, I find a what? A box plot. So I did not remove any data here because these were questions. They were questions, and this is the box plot I got. You can see here some data here were highly correlating, some questions were highly correlating here, and these ones were relatively correlating here. Some were negatively correlating with each other. So when I move here, I find a histogram with the KDE line. We can see the data, how the data distributed using this figure. So I find a pair plot, and we can see that this pair plot, this is scatter plot. Sorry, it is plotted with question 15, post impact in open source against identity effect on goals. We can see here we can see here that the positive impact on open source with 0 against question 13, which is identity effect on goals. We have 1, and again here the identity effect on goals, it is on 0, but on 4 with positive impact on open source. I find a bar graph again, a bar graph. Again, this data, it is showing that it is leftist skewed. It is leftist skewed. We plotted the distribution of age groups against the distribution of count against age groups. You can see that the most of age groups is located here in 2. Most of age groups is here, and the list of age groups is here. So when I move to the next slide, this is the plot of distribution of count against preferred languages. You can see preferred languages are located between 0 point to 1 point. You can see here. So when I go to the next slide, I find a box plot. You can see we depicted some outliers in the age groups. These are 2 outliers in the data set. So when I move to the next slide, I found a bank additional data set. This is the box plot of that data set. This is the bar graph of the data set. These are box plots of age with this variable, and the age had so many outliers in it. So that is it. Thank you very much.